Okay, welcome to week 13. Today we're going to look at correlation. Correlation and regression typically go together, and we're talking about today a linear model or linear regression. And we'll also look at some of the per package commands, particularly the maps. You want to make sure that you install the normal packages. We're going to be using the linear model, some modeling functions there. So be sure to install and load that package. You want to get some information about the modeling package, you can do the double question mark and take a look at it in that way. All right, we're going to start off by importing a CSV file. The Medicaid file, let me just bring that up for you. And here's the Medicaid file. Notice it's arranged by states. A lot of the problems today will be state level data. And we'll look at several correlations between crime rates and poverty rates, so on. So it looks like there's a website up here at another. So it looks like if I delete these 3 different lines here, we'll get to the list of the variable names. So I'm going to skip 3 and take a glimpse at this. Notice we have 9 different variables. The footnotes column there, that is not a whole lot interesting about it, but the rest of these look like integers, although their column types look to be characters. So we'll have to address that. And essentially you have for each state a listing of the number of individuals that participate in the Medicaid program. In this column over here, there's not a whole lot exciting to it. They put these numbers in scientific notation here. That's the total number of Medicaid participants in the United States. The United States is not a state, and so we're going to eventually want to address that first row there. And we can address getting rid of the United States by just giving this command, and we're going to assign Medicaid to be the old Medicaid, but we're going to subtract that first row. And here's the tidy, cleaned up frame. Still has NAs in there in some places, as you can see, and we'll have to address those as appropriate. So the next thing we're going to do is to create a table containing the mean, the median, and standard deviation for many of those numerical variables. And to do that, we are going to use the map function of the per package. I'm going to assign X to be the Medicaid. There it is. And I'm going to get rid of that last column. And so I'm going to redefine a new frame, X1, that gets rid of that last column there. And you can see that the only thing left now are those counts. This next code segment here, I'm going to change all of these character headings, these character types. I want to change them all to integers. And so that's what this piece of code does here, just changes all the current types to as integer types. And you can say it gave me a warning message that there are some missing variables, some NAs in there. Again, we will address those later. Now, I want to use these columns of numerical values, and I want to calculate the mean and the median and the standard deviation of each one. So I'm going to create a new vector, which has the number of columns in it will be equal to the number of columns in X1. And so you can see, since we have 6 different columns here, we're going to have 6 different entries into our vector. Now, this next line will convert that vector into a data frame. And if you wanted to look at it, it's not so interesting, but this is what it looks like. Notice it creates those 6 spots. This next set of commands, we're going to use the map function. Now, here's one of the functions from the per package, and it's basically a for loop. And so what you do is you give it the data set, and then you give it a function. This is a standard function. This is the mean function. And what it'll do is it'll calculate the mean of every column. And this little piece here allows us to calculate the mean without getting an error. So let me just take this out right here and run this. And then if I do X3 and take a look at this, it's going to say the mean is NA. When you have some data values that you're calculating the mean for, and some of those data values are NAs, missing data values, then it's going to give you this error. So I'm going to undo that. When I redo this command with the NA, remove the NA is true, so we're going to remove the NAs. And I do it for each one of these other statistics, for the minimum, for the median, for the standard deviation, and for the max. It's just going to reassign these into that new frame X3. And here's what X3 looks like. So you have this X4 column off to the far left, and then you've got the mean column, the min column, the median column, the standard deviation column, and the max column. And this next line, it just takes out one of the columns. So if that -1 is in the second spot, it takes out the first column. If the -1 is in the first spot, it'll take out the first row. In this case, it's going to take out the first column. When we do that, you can see that that column of zeros is now missing. In my data frame, I'm going to assign a new column, race, and it's going to consist of all of those 5, I guess it's 6 different racial groups. And it'll create a column, so each one of the rows will be labeled with the appropriate race. And not exactly what I wanted, because the race went all the way over to the right, and so I'm going to use the select command, and then it'll print it in the order that I want it. The racial category, followed by the mean of that category, and then the median of that category, followed by the standard deviation, and then I can assign that final data frame whatever name I want. So now we're going to take a look at how R handles linear correlation and regression. To do this, we're going to merge a bunch of data sets so that we have lots of numerical data related to the states in the United States. So let's take a look at the poverty data frame there. So here is the Excel file, CSV file corresponding to people in poverty. And so you can see we're going to look at column A because it has the listing of all of the states. And then we want the percent of people who are in poverty. And this is the official version. So we'll go with the percent from each state in poverty. So this number right here would mean 14.6% of all the people in Alabama are below the poverty line, at the poverty level. So it looks like I have to skip, if anything, this one right here would be the row that gives a listing of the variables. So I at least have to skip these rows 1 through 5. I don't see row 1, it must be hidden. So let's skip 5 different rows of that and take a look at it. Yeah, these are the messy column totals, but that's what we have. And then if we take a look at it vertically, the names of the columns are not nice, so we'll have to address that, but it did import everything. United States, as in the last file, was listed the total overall, so we'll want to get rid of that. All right, so we're going to call Y, this new frame Y, to be our poverty set. And then what we're going to do is just transmute. That means we're going to just look at 2 different columns, the state column and the percent in poverty column. So there they are. And we took that column D. And in this transmute function here, I relabeled this column as the state, and I relabeled the other column as the percent in poverty. So now we have a data frame. I do want to get rid of the United States there, so I might as well do that right now. Okay, we'll subtract out that first column, or that first row, I mean, and there you have it. Notice United States is no longer there. And we have 55, and so that must mean we have some other U.S. territories like the District of Columbia and maybe Puerto Rico and Guam and some other places. Remember our Medicaid data set. This is a listing of all the Medicaid recipients, the number of Medicaid recipients in each state. And now we're going to join. We're going to join this big Medicaid file with our state poverty. And we're going to, the key is going to be the state. So you can see the states over here. are common. In Medicaid, that state column is called location, but in the Y frame, the state column is called state. And so we have to give this join function where we're joining Medicaid frame with the Y frame, and we're going to join by location variable in the first, state variable in the second. And when we join these together, you can see now that the one column that I wanted to add over here, percent in poverty, you can't quite read it, but there it is, and it's lined up here. Notice that our frame shrank to 51. So that must mean that only the District of Columbia, and there were some other territories that were not captured in the combination of the two. But that's good enough for what we want to do right now. All right, now we're going to import a lot of crime data on the states as well. And so let's take a look at this crime, violent crime by state data frame. And this particular file, notice that the variables would begin about 4, so we have to skip the first 3 rows. And it also has the United States total here, but we have all of these rates in D and F, and they're different types of crime rates. So this would be just the overall violent crime rate. This would be the murder rate, and then you have the rape rate in each state, the robbery rate, the aggravated assault rate, the property crime rate, and so on, burglary, larceny, and then motor vehicle theft. And they all represent rates in per 100,000. So we don't do rates as percentages just because the percentages would be real tiny numbers. And so we do rate per 100,000 to get the rates up to reasonable numbers that make a little bit more sense, 219.9 people per 100,000 in the population. All right, so we've got all of these different crime rates that we are going to import into our Medicaid frame. So to do that, I read in the crime, take a look at it, and it has these funny different variable names. It's because we had to, the variable names were given in 2 different rows. And, all right, there's the crime frame. And so up here are the variables, and we'll have to deal with those. And then you have the different states here. United States is listed as one of the states, and you have all of these different variables. Notice that now we still have 51 rows, but now we have 20 different variables because of the joining. So this crime frame has the 51 states. I guess it's counting the United States as one of them, and I don't see the District of Columbia in this one. And then there's 20 columns to this data set. All right, I'm going to redefine a Z, and then I'm going to call D. I'm only going to grab the columns that I'm interested in, and along the way, whenever I need to redefine a variable, I'm going to do it with the state. So in some cases, I don't, it looks like in just about every case here, I need to redefine the variable. So that's why this particular command is so long. And then when we look at D, now notice up at the top, we have much nicer column headings. And again, I'm going to get rid of the United States total. I'm getting rid of that first row, and we'll take another look at it. Notice the United States is now gone. Okay, I want to import most of these columns into our Medicaid, well, what was our Medicaid frame. So here's the Y1, it's now called. And notice that the state is known as location. And then when we look at Z, the state name is known as state once again. So I'm going to join Y1, which is kind of our working file, with Z, with this inner join. And then our new frame looks like this. Notice it did get rid of District of Columbia because we didn't have a match in the two. And now we're down to 19 different variables. All right, there's one more data file that we're going to combine, and that's the state populations. So it gives us the population, or the estimated population as of July 1st on these three different years. And so I'm just going to use the 2022 numbers. It's got the states here. And instead of just getting rid of United States, I want to get rid of United States in those regions there. But at the beginning, this would be my title. And so it looks like I just want to get rid of two different rows. So let's take a look. No, I guess it's three. So let's take a glimpse and notice here are columns. Again, not very meaningful columns. And then we start off with these different regional. So we want to get rid of those regional numbers there. All right, so here's the populations data frame. And we do want to get rid of the first 5 rows, the overall United States, and then the 5 different regions there. So we're going to call W that, and then we're going to get rid of rows 5 through 1, 1 through 5. And we do it this way because -5 is less than -1. We do it as a range. All right, and then if we take a look at that, notice all the regions and United States is gone, United States total, and we're left with just the states. Now we want to join the populations to our existing file. So we're going to do so with an inner join. And we're going to join by location equals this ... 1. If you'll notice here, the title of our states column is ... 1. So we have to use this. And here's what the file would look like. And now we have 23 different columns. And here you see that it imported all of this stuff from the population file on the inner join. And now I'm going to create a Y4 that includes only those variables that I want to include in my frame. And so these are the ones that I would like. Notice that I only kept 13 different columns. They're all numerical columns. And we do have the state column, which is a character, but everything else is listed as a double. So we're ready to do our calculations on this. All right, the next thing we're going to do, all of these are rates except for the population and the number of Medicaid cases. And so what we're going to do is we're going to put those two together to get a Medicaid rate, and then we're going to have all rates in this database. So here's how we do it. We're just going to add to our data frame 4. We're going to mutate a new variable, and it's the Medicaid rate. And all of our rates are rates per 100,000. So I'm going to take the Medicaid cases, divide by the population, and then multiply by 100,000. And then over here to the far right, this column is going to be known as the Medicaid rate. And so this rate here would mean for every 100,000 people, 16,000 are on Medicaid. All right, and then so finally, since I want a matrix of all rates, I'm going to get rid of the Medicaid cases and the populations column. And so this is what it would look like. And every single one of these columns now represent rates. Poverty rate is just a %, but all the other rates are the rates per 100,000. So you would see a number like 7.3, and then you'd say in Alabama, there's about 7.3 murders for every 100,000 people. There's about 42.2 rapes for every 100,000 people in Alabama, that would mean. All right, so now we're going to explore correlation and the linear models function. Here is a way that we would calculate the correlation coefficient. And we're just going to calculate the correlation coefficient between poverty rate and then Medicaid rate. And then, this is an X and a Y. And so you want both the X and the Ys to be found, to be available. And so it says just use complete observations, has to contain an X and a Y. So we're looking for the correlation coefficient, and there it is, 0.58. And that's a fairly moderately strong correlation coefficient. It's not strong, but there is a definite relationship, positive relationship between poverty rate and Medicaid rate. Generally, in a state, if the poverty rate is increasing, then so is the Medicaid rate. In fact, Medicaid is healthcare for poor folks, and so you would think that there would be a relationship there. This next command, what it does is it creates a linear model between the two variables that you separate with a little squiggly approximately equal to sign there. And then you need to indicate what data set you're going to use. So currently we're going to be using data set 5. And then if we look at the model, it'll give us the formula. Here's the y-intercept, and here's the slope of the line. And they give you those two numbers there. All right, now we want to calculate the correlation. This thing that we calculated up here just between two of the variables, we want to calculate that between all of the variables. So again, here's a listing. And so the only variable that's not numerical is state. So we want to make sure we tell it not to use states. And here's another correlation between poverty rate and property crime rate. There it is, 0.54. And now this next table, this next command, what it's going to do is it's going to create the correlation for all of the numbers in columns 2 through 11. And so it's going to ignore the states column, but it's going to calculate the correlations in a table for all the numerical variables in position 2 through 11. So if we count them, state is in 1, and then we have 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the variables we want to find the correlations between will appear in columns 2 through 11. Let's take a look. And there it is. You have the variables coming down this column here. You have the same variables going across the top. And so you're going to see a lot of these ones. And it looks like we have our table cut off, and the other half of it is up here. So I noticed that my murder and this murder and negligent manslaughter rate column is so big that it's shown off my table. So, maybe I'll try to reduce the length of that variable. So here is a blurb that we could use to rename the murder and negligent manslaughter rate to just murder rate. It's really what it is. Okay, so I shorted the name, and so now I want to come back up here and run this command and see what we have. Well, it did shrink it, but it still didn't allow me to put all of the different columns on one row. But what you'll see is that the correlation between poverty rate and poverty rate is 1. So you're going to see 1s going down this diagonal here. And what you look for are numbers that are close to 1. So there's a very, very strong relationship between poverty rate and murder rate. And there's even, if you look around, you might even be able to find some correlations that are even stronger than that 0.72 there. Like, for example, over here, this is almost a perfect relationship between property crime rate and larceny theft rate. So those are very highly correlated. So is motor vehicle theft rate and property crime rate. So there's some very strong correlations. The idea here is that, in states where the poverty level is higher, folks are poor. And so you might have some higher crime rates. And we're kind of looking at that. You can see that there are some fairly strong correlations, but there's some fairly weak ones as well. All right, so next we're going to look at how to display those tables in a kind of a fancy way. So here are a couple of packages that you want to load and you want to install and then load in. And so the one that's very interesting is this pairs one here. So it's going to take, again, my variables in spots 2 through 11 and do a correlation, but it's going to graph scatter plots of every combination. And so this is quite remarkable that the package does this. So I'm going to run this piece right here and then take a look at this grid. So what happens is it generates a scatter plot for every pair of numerical variables. So you can see all the scatter plots together. So for example, some of these are very strong relationships, like this one here, almost perfectly linear. This is the relationship between larceny, theft, and property crime rate. So just go up or down to find the variable name in the column, and left or right to find the variable name for the other axis. And there's some other very strong ones here, as you can see. And there are some others that, there really doesn't appear to be a relationship at all. Here, rape rate doesn't appear to be linked to some of the other crime rates. And this is a good thing that you can do to visualize the relationship between all the numerical variables. This next function displays the correlation coefficients in another interesting way. Okay, so here's a correlation table. Notice that you have the ones. There's a perfect relationship between a variable and itself. And then if you find the bigger and darker the circle is over here, if you just reflect it along the diagonal, you're going to see the correlation coefficient that corresponds to that. So the biggest, bluest one would be these three. This corresponds to this one, this corresponds to this one, and this corresponds to this one. So some very strong correlations over here between property rate and these other crimes over here. And we have so many variables that it's hard to tell, but you've got the numerical representation here and a circle. And when you see the very light ones here, that means that there's not a very strong correlation. You can barely see it, but I think it says 0.03 there. And then the next one is another representation of a correlation table, but this one throws the variable name in the middle, because we know all of these are going to be +1. Unfortunately, because of formatting, it doesn't look that great, but you still have the circles here and the numbers up here. So there's the correlation table. Okay, in the next one, we're going to use facet wrap. We're going to return to this after a long time, and we're going to look at the relationship between murder rate and burglary rate. So those are just two of the different rates that we had. And we're going to do it by poverty level. Now I'm going to define a new variable level that defines these levels of poverty: low poverty state, a moderately low poverty state, middle of the road poverty state, moderately high poverty state, or high poverty state. This is a way that you can change a numerical variable into a categorical variable so that you can create categories and look at it in this way. All right, so this would be a listing of all the different poverty rates. You can see the range. The largest one there is about 18, and the smallest one's about 5.6. And so this for statement here with this nested if statement is basically going to define the 5 different levels: low, moderately low, middle of the road. And I defined it in this way just because it puts about 10 of the 50 states in each one of these 5 categories. And if you'll notice, when we look at our new file, over here to the far right is the poverty level. And so if a poverty level is 14.6, that puts them at the high level. And if the poverty level is 9.6, it'll put them at the middle of the road, and so on. So we have now a variable with 5 categories, so we can color by that new variable, and it'll put a different color on each of the different poverty rates. So we're going to do a graph here, and we're going to graph burglary rate by murder rate, and then color by poverty. And run this plot and enlarge it a little bit so you can see what it looks like. And here it is. It's a scatter plot of the 50 states, and it plots their burglary rate along with their murder rate. And then here are the different poverty levels. Notice a lot of red ones are up here. This is both a high burglary rate and a high murder rate. And so these are in the very poorest regions, the high poverty rate. Whereas the moderately low, oh boy, it doesn't have these things ordered. Moderately low is the pink, it's down here, and the low is down here. So when there's very low poverty, there's very low burglary rate and very low murder rate. Okay, I just thought I'd throw in here one piece. If you wanted to save that graph, you could do a GG save right after a GG plot, and it saves the last GG plot that you constructed. And so if I run this one, then I can go into my files. It's called crime and poverty level. And you can see when I go into my files, there it is. Okay, if now we create a facet wrap by poverty level, then we have 5 different graphs. And you can see an upward trend here. Here, maybe it's hard to know. I'd want to know what that point is and why it has an unusually high murder rate. What state is that? This one here is kind of out of whack as well. And this one looks like it has an upward trend. And for a very low, moderately low poverty level, that the burglary rates and the murder rates tend to be low as well. So low, low, low. If you have low poverty, you have low burglary and low murder. And if you have a high poverty, generally, not always, but generally you're going to have a higher murder rate and a higher burglary rate. And that's the facet wrap. And if you want to throw in the line of best fit on a plot, and if we want to color by poverty level, what it'll do is it'll put a linear model for each of the different groupings. So let's take a look, see what this does. Now this one right here, the geom smooth, it's going to draw a line of best fit. The method is the linear model. Yeah, this SE equals false, it takes away the standard error. So if you do generally a geom smooth graph, it'll throw the standard error like a shading away from the middle line. It's going to color the line of best fit red, and it's going to give it a size of 2. You can even declare the size you want to give it. All right, so let's run this one. And then here you see it. Again, the points are colored by poverty level. You got this thick size 2 red line coming in here. And that's how you draw the line of best fit. Now, if I took this out, then it would throw in the standard error piece. So let me show you what that would look like. See the shading, the standard error that goes away from the line. If you say SE is equal to false, it'll take that shading away. Okay, in this next one, we're going to do the same thing and find a line of best fit. But up here in the aesthetic, you can see that we're coloring by poverty level. And when we do that up here, it's going to draw our 5 different lines of best fit using a linear model based on the poverty level. So let's take a look at what we get with that one. So there you see this line. Now notice that the red line only exists for the span of within the red points, and the blue ones only span within the blue points, and so on. But it looks like all of these have an upward trend, and that is as burglary rate increases, so does murder rate. Some of those lines are steeper than others. So probably for the moderately low group, it doesn't look like there's a very strong relationship between burglary rate and murder rate. Okay, and finally, we're going to display the summary statistics for a collection of some of the variables in our rates function. To do this, the summary function does a good enough job. And in fact, it does give us these 6 variables. So I'm just going to do summary of Y7, and there you see, it's got poverty rate. Here are the 5 number summaries and the means. Then you got murder rate, same numbers, and robbery rate, same numbers. And we could put this in a different frame if we wanted, but the generic output works just as well. Okay, so you're going to have some similar tasks in your homework for this week. And good luck experimenting with linear models and correlation in R.